Alright guys, welcome to this page of the notes, and again what we're doing is we are working our way through these problems where I give you a polynomial and ask you to find all of the rational zeros, irrational zeros, and imaginary zeros using the rational zeros theorem and the factor theorem of polynomials. So here we go. The first thing I need to do is create my list, and again I've made things very easy on you by making that leading coefficient a 1. So a naught is equal to 15, a n is equal to 1, which means my list is just going to be all the factors of a naught. So the factors of 15 plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15. So a naught over a n is going to be equal to plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15. Slightly longer list than what we have had in the past, but nonetheless we'll systematically work our way through it until we find one that works. So possibilities, ran out of space, sorry, possibilities we'll abbreviate, and I don't think that's abbreviation, but whatever. Alright, so I'm going to have x, I could do x minus 1, x plus 1, x minus 3, x plus 3, x minus 5, x plus 5, x minus 15, and x plus 15. Again, that list of possible factors comes from my list of possible rational zeros. Set each of these equal to 0. X minus 1 equals 0 means x is equal to a positive 1, right? There it is, positive 1. X plus 1 equals 0 means x is equal to a negative 1. There it is, negative 1, right? So I just work my way through this list, writing my possible factors. Now what I do is I go through and I start at the top, work my way through the list until I find one that gives me a remainder of 0 when I do the synthetic division. Again, guys, I have not worked these problems out ahead of time. You are watching live math. We are doing this together. I have no idea how this is going to work out, right? So if this is the one that works, we're about to do a whole lot of math together until we find the one that works. Here we go. X minus 1 equals 0, which means I'm going to do synthetic division with a positive 1. Put that inside the box. 3, 2, 1, 0. Everybody's there. I don't need a placeholder, so it's going to be 1, 1, minus 17, and 15. Bring down the 1. 1 times 1 is 1. That gives me 2. 1 times 2 is 2. Negative 17 plus 2 is going to be a negative 15. 1 times... Wow. How about that? So it turns out we got lucky. I've got this giant list of possibilities, and the first one is the one that works for us, which is awesome. Really makes you feel good when that happens. But anyway, I worked through that first possibility, and we got a winner on our first try, which is fantastic. I'm actually really kind of surprised that that happened. Makes me feel good. I picked a good example problem. But anyway, I just did the synthetic division, and it worked out the way that we wanted to. I got my remainder of 0. So what that means then is I can rewrite the polynomial I was given as the factor and the reduced polynomial. So I called it f of x. We will call it f of x. And it's going to be equal to my factor, which was x minus 1. And my reduced polynomial, which is going to be x squared plus 2x minus 15. Okay. Now what I need to do is I need to see if there is some way, right? If there's some way to factor this guy. And actually, it looks like I will be able to factor it into two binomials. At least it appears that way. Let's check and see. The easy bit. What two things multiply to give me an x squared? Well, that's an x and an x. The slightly trickier bit, I need two numbers that multiply to a negative 15 and sum to a positive 2, which I believe a positive 5 and a negative 3 will work. If I do a negative 3 times a positive 5, that's minus 15, and a negative 3 plus a positive 5 gives me the positive 2. So it does. Set this equal to 0. Zero product property lets you split them up. X minus 1 is equal to 0, which means x is equal to 1. X minus 3 is equal to 0, which means x is equal to 3. And x plus 5 is equal to 0, which means x is equal to a minus 5. I had a third degree polynomial. I get 3 zeros, which means I'm confident that I did it right. And one last thing I want to point out to you. It turns out in this problem, all 3 of my zeros are rational. Please notice, all 3 of these guys show up in my list. X equals a positive 1, which is right there. X equals a positive 3, which is right there. Also notice that the factor x minus 3 was also in my list of possibilities. Right, there it is right there. Which means, right, if I had chosen this one and done the synthetic division, I also would have gotten a remainder of 0 because x minus 3 is a factor. And then this one, minus 5, there it is right there. There's the minus 5 in my list, right? There it is in my list. And its factor, x plus 5, right there. Also in my list of possibilities, which means if I had done synthetic division using this factor, I also would have gotten a remainder of 0. So any one of those 3 would have worked. All 3 of my zeros were in the list that I created. Guys, thanks so much for joining me for this set of videos. I have really enjoyed going through chapter 5 and looking at polynomials with you. I can't wait to see you next time. Bye.